Hey guys, and welcome back. Now, to close off this skill, I want to discuss with you two more concepts. The first one is related to SMART. Now, SMART is an acronym and it stands for the Self-Monitoring, Analysis and Reporting Technology. Now, one thing to note here, which is quite important, is that this is not Linux specific. So it's actually not related to the Linux operating system. Instead, this would be technology integrated with your actual hard drive. The difference here, what we're actually talking about, is that on Linux, we actually have some tools which we can use to access this information which is running on the hard drive itself. Now, one thing which is a little bit limiting is that if you want to be able to access this information, you have to be on a real hard drive. Now, you may remember that what I'm using within this course here happens to be a virtual machine. So if you are doing the same at home and following along, you are not going to be able to access these features. But despite this, the important thing we have to know is really what this technology does, i.e. it allows you to actually monitor your hard drive in such a way that you can monitor for potential errors. That way you may be able to spot these issues early and take preventative measures to correct these issues before any major problems arise. Now, in order to be able to access this SMART information, what we would have to do would be to enable what is called the SMART D daemon. So, SMART D. Now, once this daemon is actually up and running, we will have access to a command called smartctl. Okay, so on the hard drive itself, we will have smart technology. On our Linux operating system, we can start a particular daemon called smart.d, which will give us access to the smartctl command, which we can use to interrogate that information. So that really is the architecture we're talking about now. Smart itself is not Linux specific, but these tools, i.e. this daemon and this command, will allow us via Linux to access this information and make use of this information. So if I say sudo apt install smartmon tools, this will begin installing smartmon tools, which will allow us to start this daemon and ultimately use the smartctl command. So now I can say man smartctl. We can see here this is going to allow us to control and monitor our smart disk. Now, like I say, I happen to be on a Linux virtual machine, i.e. I don't have access to a real hard disk. But if I did, the way I could actually utilize this tool is just by simply saying smartctl, and I can say -h if I want to generate a health report, and I can specify a particular disk I want to target, maybe say SDA. So if I hit enter with sudo privileges, notice we're going to see here that in my case, unfortunately, it's going to tell me that the device lacks smart capability. This is because, like I say, I'm on a Windows machine using VirtualBox technology. But if you run this command in your own home, if you happen to have a real Linux computer, you should be able to generate a smartctl health report, which can give you really vital information relating to potential errors with your hard disk itself. Now, the other topic I want to talk to you about is one called Autofs. Now, this command here is very, very useful indeed. So you will recall that when we want to statically mount a particular file system so that it automatically mounts when we reboot our system or our system boots up, we would do such a thing by specifying this information within our etc.fs tab file. Now, here is the deal here. When we happen to specify that a system should be mounted within fs tab, what did I just say there? This means that when the system is booted, those specified within fs tab will be mounted. So every time we boot the system, the mounting process happens. Now, let's say we wanted to be maybe a little bit more efficient in that we didn't want our file systems to always boot, or always mount, should I say, when the system boots. What if we just wanted them to mount automatically on the fly only when needed? Now, this really is a candidate for when you want to use this tool called Autofs. Now, if we want to be able to use Autofs, there are some configuration files that we have to understand to facilitate this behavior such that our file systems will only be mounted when needed. Let's actually look what those configuration files are. Now, the first thing I will say is that we would have to actually install Autofs. So I will say sudo apt install Autofs and hit enter. And if I hit Y for yes, hit enter, this will begin the installation. And we can see here we are creating some configuration files. We'll talk about these very, very shortly. These ones right here. Okay, now, so within the etc directory, we will now have, after our installation, these configuration files. So if I do an ls, we have a ton. So what I will say here is auto and wildcard. So now we can see here these files relating to Autofs. First one is this one here called AutoMaster. This is the first configuration file we want to configure, and this will be our main configuration file. So what I will do is I'll say sudo nano etc auto.master. If I hit enter, we can see here this is a sample AutoMaster file, and if I scroll on down, what I'm going to do is add in some information. Now, the first piece of information I'm going to add here is going to be the base directory where we want to create these Autofs entries. What I'm saying here is I'm going to create a directory called nfs, okay? And now what I'm going to do is to specify the configuration file which I'm going to read in here. So I'm going to say within the etc directory, look in auto.nfs. Now, right now, this configuration file does not actually exist. We're going to create this configuration file, okay? So I'll save this right here, okay? So notice here, auto.nfs does not exist. What I will do is I'll just create this file. So it is now created. In fact, let me just use super user privileges, of course. So now if I check my command, auto.nfs is now present, but it will be an empty file. Now let me go in and edit this file that I've just created. So I'll go in and say sudo nano auto.nfs and hit enter. Like I say, blank file right here. Now within this file right here, what I'm going to do is I'm going to specify my mount point. So if I just happen to give the value, let's say videos, this is going to be the mount point. Now what I'm going to do is to specify what device do I actually want to mount. So this could be a particular disk, or a very good candidate for this type of technology would be if I wanted to mount information from a remote server on my network that was actually sharing information. So let's imagine there was some type of server on the network. Let's maybe say the IP address was 192.168, I don't know, 1.1 maybe. And then I will do a colon, and let's say maybe on that server there was a folder. Let's just say it was called shared stuff, and within this directory there was a dedicated folder for videos. What I am actually saying here is that if I happen to go into my own local system and I go into the NFS folder and then go into a folder called videos, when I access this location, the information on this server here, i.e. the shared stuff videos folder on this server, that is going to be automatically mounted by Autofs, meaning that it's going to be transparently available to me. Just the way we've seen before in the previous skill, I just cd into this particular directory on my file system. And like magic almost, the information on this server is just going to appear and be mounted on my local file system. Now, if I just happen to save this right here, and escape out, this would not immediately take effect. What I would have to do would be to restart my Autofs service. So I could restart this right now, and now the information would take effect. Now, you might be wondering that when I said I would have to browse to NFS videos, how on earth did I get this? I.e., why is this folder called NFS? Well, this is because this is what I specified in that main configuration file. If you happen to remember, and we go back into auto.master. So once I go in here, this is the name of the folder I have defined here, and I'm linking it to this configuration file I just created. And within this configuration file, I have specified a folder called videos. So really what we're doing is we're combining the two. We're combining this base folder here, NFS, and then what is defined within here, which we saw at the very left-hand side, would be videos. And we bind it to, in our case, that particular remote server. So like I say, all we do is just say cd nfs, and again go back in, cd nfs cd videos, and the folders here within this particular server automatically are now available on the fly. And once this happens, this mount will now be activated. But here is the thing, if we happen to not use our particular mount point, which is NFS videos, after a certain amount of time has elapsed, something like say 75 seconds of not being used, automatically this is going to be unmounted once again. But if we happen to once again go back into our NFS directory and then into our videos directory, automatically once again, this particular folder on this particular server is going to be mounted and available to us over our network. So as we can see here, the Autofs command is really cool. It is very efficient. You don't have to use it with remote network shares. Like I say, you can use it with different disks, whatever it may be. But this happens to be a very good use case for using Autofs. Okay, doke, so that is us for understanding smart technology as well as Autofs. I hope this has been informative for you, and I'd like to thank you for viewing.